All right, everybody. We'll go ahead and get started. It looks like I think everybody's here. So this week will hopefully be a little bit shorter than last week. We're just going to go over any questions you guys have about the data processing and analysis, and I'll go a little bit into more detail about the format of the actual lab report itself. And then at the end, we'll talk a little bit about the Python stuff and just kind of gauge who all is actually interested in that. So let's launch right in. So it's like I just said, this week we're just going to continue our data processing and analysis from last week. We can go over creating those professional plots using Excel. I'll talk a little bit more about the manuscript itself, and then we'll discuss the Python stuff for Wednesday. So this is the same slide from last week. The general concept here is we're going to be structuring this lab report like it was a manuscript being submitted to advanced materials. And this just gives us a template for how to structure the actual paper itself, as well as like all of the typesetting and formatting and stuff like that. So I'll upload this template document that I made. I kind of modified the one that's actually from advanced materials, and I put a little bit more information in there, as well as like some example figures and stuff like that, just so you guys have a little bit more to work with. But this is like basically what the header information should look like. So you should have a title that's descriptive, but doesn't contain too much detail. Put all the authors. You should put yourself, me, and I guess Professor Wynn, and then do all of this stuff like the authors' addresses. The corresponding author will be you, so you'll put your own email address there, and you can put your affiliation as the University of California and just look up the actual address for that. The keywords and stuff are not super crucial. There's something that people do when they submit manuscripts just so that they're more easily searchable on Google and stuff like that. You should also include an abstract, which should be really short, but just basically outlines the experiment a little bit and then discusses the most pertinent results. This is an example of kind of how figures should be appearing in the text. So they should all have a caption, which appears above them with some text explaining what it is. You don't have to include reproduced with permission, stuff like that, because we're not going to be, even if you copy stuff from other people's papers or whatever, I don't really care about obtaining permission. Obviously, we're not submitting this for actual publication, but this is the general format of how things should look. And so you can see here that we have labels for the subfigures. We have A and B. These are basically just text boxes that are superimposed on these figures here. And you can also see that, the formatting of the graph and stuff has been modified from what it would normally be in Excel, just to look a little bit nicer and be a little bit easier to understand. Tables should look approximately like this, and this table is again in that document that I'll be sending you guys so that you guys can copy this formatting. This is just a much cleaner way of showing data than the built-in tables that Word has. And they should also include a caption over them, which includes the details about what the table is. And then if you need footnotes for your data, you can put them below like this. And then equations, you guys should probably include some equations in your report. I don't know exactly which ones will be relevant, but that's up to you guys to decide. You should always input them as actual equations using the built-in equation editor and not just text. And then each equation should also come with a label so that you can reference it in the text. And then references, these are a bunch of different formats for different types of references. Most of them will probably be journal articles or books. You might also find presentations and stuff like that, but this is just the general format for them. So make sure you follow the formatting here. Okay, so this is a summary of basically everything that you need to do for the actual data part of this report. And so from this point on, I'm going to basically just kind of hand it over to you guys to ask questions and things like that, and then I can hopefully go into some detail about how to actually do these things. So does anybody have some questions that they brought for what to do with this lab?
This is a real overview. The only thing we use OpenCrom for is to visualize the graphs before we get in and start using start graphing them ourselves in Excel. We're not exporting the data because you already did that for us in the integrated solutions and on this. All right, perfect.
Yeah,
I just wanted to make sure I wasn't missing something from OpenCrom carryover.
Yeah, you should export the data from the example files to generate like some example chromatogram and mass spectrum peaks, like I talked about last week. But yeah, the actual data that's in those raw data files does not correlate to the integration reports, just because that experiment was really old and I wanted to give you guys some more realistic data. So is that clear? Like you still should, you should still export some of the data from Open Chrome so that you can plot it on your own, but you don't need to actually do any of the like peak area or retention time analysis for that data. Does that make sense?
Yeah, thank you.
Cool. So I guess I'll ask a question. So by a show of thumbs up in the Zoom thing, how many of you have been able to normalize all of the standard data and then get the calibration curves for the different analytes?
Could you actually go over how to normalize the data again?
Sure. So let's pop on over to our integration summary thing. So if you guys want to follow along, you can open up this integration standards. And you remember last week we saved this as an actual Excel document and not a CSV so that we can save multiple sheets and do some calculations and stuff like that. So the summary contains all of our data, which has been pivoted from something like the report, which is given like this. So basically all these data are just transferred over, transposed, so that you get something like this, which has all of the retention times and areas. And then the problem is that the retention times have some drift. And so we're using this D8 toluene standard. And so we're going to say basically that we know that this is D8 toluene, this 100 mass signal. And so we're going to take the average of that retention time, and we're going to use it to correct all of these retention times to basically be identical to each other. So this cell down here, you can see that this is calculating just the average of the retention time. And then this cell over here is calculating the average of the peak area. And then to calculate the normalization factors for these, so for the retention time, we're basically just subtracting the value of a given sample run for the retention time from the average value. So this gives us the factor that we add to each of these retention times to get them to all be normalized. So I know this is kind of complicated to explain in words, but hopefully you can see what the formula is doing. So it's reading this average cell, which we've locked using the dollar signs there, and then it just goes down the column. And so if you go down here, you can see that it's just going for each row and subtracting that value from the average. And then same thing for the normalization, except for instead of subtracting it, we're dividing it in this case. So we take our average peak area and then divide it by the given run. And then these factors are applied to each of the different columns here to make sure that eventually our 100, so our D8 toluene peaks, you can see that all of the retention times become the same and all of the peak areas are also exactly the same. So that's what this normalization factor does. And if we apply that same normalization factor to each of the other retention times and peaks, the effect that it has is it generally tightens up that grouping of the retention times. You can see there's still a little bit of variation in there, but that's expected. These are experimental data in theory. And then the peak areas as well also get much closer together. So you can see these are all, you know, pretty close together. There's some variation there and stuff like that. And you guys can do some analysis on your own about, you know, whether or not you should include outliers in your calculations. That's something you can discuss in your reports. And then once we've got these data, the final step to getting our calibration curves is we want to plot basically these normalized areas versus the concentration for each of these standards. And so remember what we did is we built this little spreadsheet here, which I haven't really labeled again, but you guys can go through and make sure it's labeled appropriately. But we took our data that contained our actual solution preparation details. So these are microliters of each of these analytes and then the solvent they're dissolved in. And then remember, we did this calculation that basically calculates the concentration of these stock solutions using the molecular weight and the densities, which we looked up online. And then for the final dilution, we took 20 microliters of each of these stocks and then diluted them into another milliliter of the 1-chlorohexadecane plus 10 microliters of the standard, and then 50 what's this 10 microliters from? I don't remember what that's from. Anyways, they're all, these are the final concentrations. And so the way that we relate these to our normalized data, so this corresponds to standard 1, the MTBE peak. So this is the 73 peak concentration. And so if we look back here, so all of these areas here should have that concentration for MTBE. And so we took the data from here. So we took our concentrations calculated from our sheet over here. I know I'm switching around pretty quickly back and forth, but so this is our concentration of our MTBE in stock solution 1. And then we just applied that for all the ones that are standard ones, so all of these S1 values, and then we copied the area values that are normalized. And then we, let's see, what do we do? Oh, we scaled our concentration by a factor of 1,000 to get it in millimoles per liter instead, just so that our axis here was more readable. Then we just basically plotted all of these things versus each other. And this gives us a calibration curve for MTBE with a line of best fit and then an R-squared value. So 10 should be a 20, says Brandon. So what is the 20 again? Can someone remind me from the actual calculation what that 20 is coming from?
You're summing up the solution down there. So you've got, oh no. No, I can't remind you. Sorry.
No worries.
I was thinking that before last class, and then I saw it again, but I don't remember where it's coming from now.
Yeah, so all of these, we're adding 10 microliters of something, or we must be anyways. Does someone have the lab handy? I can't remember off the top of my head. Let me see if I can open it real quick. GCMS data here. So we'll throw it up over here. So let's scroll down to where we actually have that data. So let's see, 20 microliters, add 1 mil, and then add 50. So why are we adding 10? I think that might just be a typo. Let's see. So if we remove that 10 from our value here, 1,000 plus 10 plus 50. Oh, this is an M1V1 equals M2V2 calculation, right? So this term here should be V2. So it's going to be, yeah, you're right. It should be 20. That's it, because it is the same 20 as this one. I think that's the problem that we had there. So let's copy that down. And then let's make sure, I don't remember if this is going to work, but that looks like it's going to just adjust those concentrations by a little bit. So actually, to make sure that this is more robust, we can go back to our column here, and we can set this now to that value, and let's lock it in for now. And then we'll copy this down for all of those ones. This one for standard 2, we want to lock it into that one. And I forgot to hit F4, so let's hit F4 there. That should do it, and let's drag that down. And you can see it's not changing by very much, obviously, because there's 10 microliters total. But let's do it for the final one. And I again forgot to hit F4, and now just drag that one down. And that one barely changed at all. So that now should just adjust all of these appropriately. And so your goal is to do this for all of the different analytes. So the same thing for the 91 peak, which I believe is toluene, 78, which is benzene, and then the D8 toluene we don't need to do because that one's our standard. You could additionally plot these ones versus each other, but the concentration is exactly the same for all of them, so it's not going to actually matter. So is that clear to everybody? And then formatting this graph, you guys remember, you guys can go back to the recording from last week to show how to do like all the tick marks and the scaling and stuff like that. And then remember that you want to export these as a picture to embed them in your final document so that it doesn't get all screwed up when you change sizes of things. All good on the calibration curves? Minimize all my crap here. Any other questions about this part of the lab? Do You guys understand what to do next once we've got all of these? Okay. So I'll just briefly kind of summarize what you need to do. So I did not give you the integration summaries for the gasoline. So you basically have to take all of these data and then construct the same kind of summary table where you pivot all this stuff. And then using your standard data, you want to identify which of these peaks, so all of these peaks here correspond to a mass chart, an ion mass of 73. And based on the data, we need to determine which of these, if any, correspond to actually MTBE. So if we look back at our summary table, you can see that the retention time for 73 should basically, once we normalize it, should be basically 1.32. So looking back at our gasoline, it's not clear before we normalize this if any of these actually correspond to MTBE, right? But let's look at the 91. So this is the toluene. Let's go back and check our integration summaries. So the normalized toluene retention time should be 3.28 approximately, or 3.29. So it looks like this first peak has to be it, right? Or once we normalize it, it should be much closer. But these ones that are around 6 minutes, even though they have the same mass or ion mass of 91, they can't be toluene because they're eluting so much later in the experiment. Even though the peak area is higher for this one than it is for this one, this is the one that you're going to use to actually calculate the concentration of toluene in sample 1. Does that make sense to everybody? A thumbs up if you're following. Cool. Okay, so yeah, I'm not going to go through the procedure for this because I want you guys to kind of work on this on your own to figure this out. But let's see. So again, like we didn't get this going last time. So thumbs up again if you've been able to normalize the calibration data and plot each of those peaks, or even just any of them. Have you basically reproduced this plot? And if you've done it for more of them, great. So no one's done it yet. Okay. So yeah, at this point, we can sit around together. What do you guys think? Do you want to split up into like breakout rooms and work as kind of lab groups, or do you want to all stay together in this one room and work together to get these calibration curves done?
Stay together.
Okay. Like stay together because we can keep recording, so I can reference back to it later.
Fair enough.
Yeah.
Okay. So yeah, that sounds good to me. So why don't we start working on that now? I'm going to, I guess, mute myself and turn off the video unless somebody has a question. So work on this on your own, and let me know when you run into trouble or anything like that, and then we'll proceed. Maybe, I don't know, give it 10 minutes or so, and then we'll proceed from there. Sound good?
Yep.
Okay. So yeah, I'm gonna pause my pause my mic and my camera, but just let me know or type in the chat if you have a question. Alrighty. I know it's not quite 10 minutes yet, but is everybody ready to move on? Also, has anybody been paying attention to what I've been doing in the sheet here? Just making it so that everything gets automatically filled in. Yeah, so ready to move on, guys? Or no?
Yeah.
Okay. So yeah, of course, if you run into problems later when you're processing this on your own and stuff, you can always ping me on Slack and I'm happy to help. But yeah, like, so I don't know if anyone was watching, but I, started filling in these formulas here to just do all the lookups from the other data so that you only have to change it in one spot. Is that going to be easier in Python? Yes. It's going to be a little bit more complicated to understand probably because we're going to be using code and pandas to do this stuff. So you won't be able to see all the data necessarily, but it'll be faster and easier. And you basically just have to type a couple lines of code. It'll be faster. Yeah, so I went ahead and did the toluene calibration curve as well. Probably you should change the colors and stuff so that they, I don't know, you want to pick consistent colors for each of the analytes and stuff like that, just so that the reader can more easily follow stuff. But so here's an example calibration curve for the toluene. You can see it has a different formula, different R-squared value, stuff like that. So yeah, just using all the same data and just looking up all the stuff from these things. So I use this thing, and I think I talked about this last week, where you basically insert this table thing in Excel, and it allows you to more easily like access that data from other parts of the workbook, which is what I was doing here, looking up those table values with this VLOOKUP function. Okay, so that's enough of that. Unless anybody has a question or anything like that, then I'll move on to talking a little bit about the Python stuff, or at least get us started with the installation and whatnot. All right. So I guess I can start here and just kind of go through these really quickly. So I'll obviously upload this this PowerPoint as well, and it has some more detail about what you guys should be including in each of the sections. This isn't an exhaustive list necessarily, so use this to kind of structure your reports and stuff like that, but whatever you feel like you need to include additionally, go ahead. So introduction, here's some stuff for the results and discussion, conclusions, and as this is the same slide from last week as well, so here's some things and ideas to research for the report. And again, the software links for doing some of this stuff. So moving on to this Python stuff a little bit. So a couple people said they were able to get Python installed. So has everybody at least installed Anaconda and maybe not created the environment yet? And if not, then why don't we go ahead and do that now? I think it should work for everybody. I'm a little bit worried about, is it Lily who has Windows 7? We might be able to figure something out with that, but yeah, so why don't we go ahead and do that, and then we can troubleshoot together the Anaconda installation. So there's installs for Windows and Mac. You just have to choose the architecture that's appropriate for your processor. I think they have an ARM or an M1 distribution, or if not, then hopefully the 64-bit version also works on that architecture. So here, why don't I go to anaconda.org. So you can go to this download thing. The individual thing is free. And then you just select the appropriate version. So I hope this one works on whoever has like the new version of a MacBook or whatever, which has the ARM processor. But if we run into issues, just let me know and we'll figure it out.
So we download the one that says graphical installer or the command line?
Up to you. If you're comfortable using the command line, you can do that, but the graphical installer will walk through everything for you. And I'm assuming, like, I don't have a Mac personally, but I think you just download this and then you extract it and then just like drag and drop into applications or something like that. I guess I can start up my Anaconda as well. I don't actually use it very often from Windows, but see what it does. It's really slow on my Windows for some reason. Hopefully it's faster on your computers, but we'll see. And I guess if you're not at all interested in learning how to do this with Python, you're totally free to leave now if you want, and just ping me on Slack for questions and stuff like that. But I will say that learning this skill is going to be super useful in your job searches. If you know how to use Python or can add that on your resume, then it makes you way more hireable than people who don't know how to use it. Oh God, so many things are open. Okay, so yeah, this is eventually what you'll get to once you have Anaconda installed, and then you can run this program called Anaconda Navigator. Was everybody at least at the point of downloading the installer?
Yeah, I'm still downloading it.
Yep.
Okay. Yeah, it might be slow depending on your Wi-Fi. I realize that. If you have got this up and running, the Anaconda Navigator thing, then you can navigate to this tab like I'm here with environments, and then you'll be clicking this button down here to create a new one. And then you can name it something like I've done Chem153, and I'd recommend not including spaces in your environment names because it just makes it easier. And then Python 3.8 is fine to use. I think the newest versions of Anaconda will probably have 3.9 installed for Python, but we're going to use 3.8 for now, and that should be plenty. And I'm not going to make a new one because it takes forever.
You said 64-bit was fine, right?
It should be. It depends on your operating system. If you have a newish version of Windows 10, then it's most likely 64-bit. But if you run into problems and it won't work for whatever reason, try the 32-bit one instead.
Question.
Yep.
So you need both the installers if you have a Mac?
You should only need the graphical one. And the graphical one should install everything, including this Navigator program.
Thank you.
Yep. So once you actually get the hang of working with programs like this, it's easier to use things from the command line. So I can show you real quick. Open a terminal. So on Windows, this is the equivalent of the terminal program on Mac. It's the CMD exe program, which is actually hot garbage. But you're able to do things in this window, like install packages and stuff, which instead of clicking them on this graphical interface, it's actually a lot faster to do it from here. So once we get to the actual lecture on like Wednesday, I can go through some of that stuff with you guys. But yeah, graphical interfaces are convenient. So just out of curiosity, is anybody at this kind of screen yet and has a environment kind of loading, got a blue bar going here, or it's already done? Richard, you have an environment already created? Did you install some of the packages that we need? No worries, Valeria. I know it'll take time depending on, like I said, your Wi-Fi. It's a pretty big package. Okay. So yeah, if you get to this point, we need to install a couple different packages that we'll be using for the data analysis stuff. And so you'll want to switch this thing up here to not installed. And then you can start searching for the things we'll need. I already have them installed on this environment because I've been using it for other things. But you'll need pandas, it's called. And it's not going to show up on mine because, like I said, I already have it installed. So if I switch back to installed, you can see I've got pandas installed. It's version 1.2.4. You'll also need, pandas doesn't show up for you. Okay, so if that isn't working, click this update index button, and that might help. And if not, then we can go to the command line and get things working that way. The update index worked. Good. So yeah, pandas will need SciPy and probably NumPy as well. This one might get installed the same time you install pandas because it's a dependency of it, but that's fine. And matplotlib. This is the library that we'll be using to generate graphs.
What was the one before that?
NumPy.
Okay, thank you.
Pandas, SciPy, NumPy, matplotlib. Yes, thank you, Richard. And we'll be working with Jupyter notebooks to do most of the processing. I personally prefer Jupyter Lab, which actually, so I don't have it installed in this one. But this one here, it contains Jupyter notebooks inside of it as well. And it's basically just a slightly more easy to use environment than just pure Jupyter notebooks. So I'd recommend installing Jupyter Lab, but Jupyter Notebook is also fine. Should have all the functionality as well. So let's do another check-in. How many people have the installer downloaded already? The thumbs up.
I have the installer downloaded. It's just installing now.
Okay, good. It looks we're making some progress. So yeah, once you've run that installer, then you want to open up this Anaconda Navigator program, which on Windows, if you type Anaconda Navigator, it should show up in your apps, assuming that everything installed correctly. Oh, there's another step where it asks you if you want to install Python into your path. Did anybody see that when they were running through the installation process? So I'm trying to remember if it's best. It's probably okay to go ahead and do that and click yes, put it in my path for now. If you already have Python installed on your computer for whatever reason, that might start to screw things up on Windows especially. But we can cross that bridge when we get to it. So for now, yeah, just click yes for add Python to path. And if you didn't or skipped it, we'll figure it out. No, NumPy, you don't want to download the NumPy devel library. That's the one for if you wanted to contribute your own code to the NumPy library. Just NumPy by itself is fine. That's NumPy. And like I said, I think when you install pandas, it'll probably also install NumPy because pandas uses NumPy in its own calculations. So thumbs up, how many people are at the stage of you've made a new environment and you're looking for the packages to install now?
I'm on the blue bar for creating the environment.
You're on Windows, so
Yeah, I am.
yeah, for some reason it's really slow from this navigator window. I don't know why, but yeah. So yeah, once that's done and you've made the environment, you do have to like click on it to load it to make sure that you're installing the packages in that environment. So like I have a couple of them here, but if I switch between them, you'll see that the packages will change, but it's also super slow for the most part. So this one, for instance, is a Python 2 environment that I have set up for like an old project, but yeah. Thanks, Richard. Yeah, if you install pandas, it probably will also install NumPy, but it doesn't hurt to go through and explicitly install it as well. Yeah, so once you've made that environment, make sure you click on it. It'll take a second to activate it. You can also work with your base environment and install packages, but it's really best practice is to create a new virtual environment like this, basically for every project that you do. So for this class, I'm hoping we'll be able to do everything we need to for GCMS in here, and then maybe we'll do a little bit with the HPLC lab as well, although there's less analysis for that lab overall, so we might not need to.
My environment was created, but I can't find pandas on the not installed
Yeah,
tab.
click this update index button.
Okay.
And that should go and fetch all of the packages that you can install. There's also, so let's see. Yeah, so channels, hopefully you guys also include CondaForge, which is where a lot of this is all stuff that you don't really need to know for now, but there's a bunch of different places that Anaconda will look for packages when you want to install them. CondaForge is a big one. So if you're having trouble finding something, make sure that's there. You can also update the channels from here to make sure everything's loaded appropriately. So yeah, the list of packages we need, Richard typed a little bit. We need pandas, SciPy, NumPy, Matplotlib, and then I would also recommend Jupyter Lab. I think that should be everything that we need.
So I have I finished installing, but I'm not really sure how to open up Anaconda.
Okay, are you on Mac or Windows?
I'm on Windows.
All right, so if you click your Windows key or the start thing and just type Anaconda, it should come up.
Yeah, I see the prompt,
You
the
see
Anaconda prompt.
Anaconda prompt. You don't see Anaconda Navigator?
No, I don't.
So when you were going through the installer.
Oh, I see it. Never mind.
Okay, good.
Okay.
I think yeah, sometimes there's an option to not install this, but it usually does it by default. So then, yeah, I guess I haven't gone through this. So once you select a package here, let me just pick a random one that I haven't installed yet. Actually, let's just do Jupyter Lab. Why not? Jupyter Lab, and then you select it. This hasn't downloaded it yet, so you can select a bunch of packages and then click apply down here when you have all the ones that you want to install. So I'm just going to install this one right now. And actually, I'm going to install one more thing just because I need it, because I know that I need it to work. Never mind. All right, we'll just do Jupyter Lab. And this also takes a long time on Windows. It might be faster on Mac. I've never used Anaconda Navigator on Mac before. But this is why I typically use the command line instead of this GUI, but it's fine. Oh, it's got a bunch of different dependencies, that's fine. All right, so thumbs up. Who's got an environment made and all the packages installed already? Oh, good. Lots of people faster than my computer. So once this finishes installing, then we'll start up an example Jupyter notebook. Yeah, it pops up all these command line things all the time. It's really annoying. But. Okay. So once you've got your packages installed, you can go back to this Home tab here. And then from here, you can launch certain applications. So like, for instance, I've got the Jupyter Lab, which I just installed, and the Jupyter Notebook. Like I said, Jupyter Lab is just basically a wrapper around Jupyter Notebook that has a couple extra things in it. So I'm going to launch that real quick. And this should automatically open up a new browser window. So it's going to run, it's creating an environment where we can run and access our Python code from the browser and also the files. So like show you once we get here. Okay, so yeah, we're going to select Python 3 for our kernel. That's fine. I don't know why it opened in this folder, but anyways, it'll probably open up in your basically your user directory. And so you'll have to navigate to like a place where you want to store the data and the code for your project. You can make that folder wherever you want. You can see I've got this code thing that has a couple different projects and stuff in here. So why don't I make a new folder in here, just call it Chem153, just for fun. I'm actually going to close this notebook and discard it. So within this Chem153 folder, you can create new files from here if you want. So if you wanted to just make like a new text file, and then you can rename it to whatever you want. Rename, hello. And then you can also open it and edit it. Hello. I don't know why it's got this blue thing here, but that's fine. So is anybody at this stage yet where they've got a Jupyter Lab or a Jupyter Notebook open and then some directory made? Richard's already there. You already had it installed though beforehand, so no worries if you're still catching up, that's fine. Anybody running into problems installing packages or anything like that?
Yes, kind of. Like I'm trying to look up the packages, but some of them aren't showing up and I'm doing the update index.
Okay. Which ones are you looking for?
I was looking for the pandas one.
Pandas.
Is it the GeoPandas, the one that we're supposed to, or pandas profiling?
Just pandas.
Oh, okay. Yeah.
So that one's not showing up.
No.
All right. So click on your channels thing here, and does it have Conda Forge?
Let me check.
Okay.
No, it just says defaults.
Okay. So click on this add thing, and then try typing Conda-Forge like it's written there. And then you should be able to add it once you write that.
I typed it in, but it's coming up like a little stop sign with the exclamation point. Let me see. Let me try it again.
Yeah, so I've never actually added channels like this through this GUI, so I'm not sure how to work. And you're on Mac, I'm assuming?
Yeah,
Okay.
yeah, it's still giving me the same exclamation point. It says invalid channel.
Invalid channel. All right, so let's Google how to add channels Anaconda Navigator. Richard, yeah, if you can add it that way. If not, let's see. Click the add button. Okay, so we might need to get like a URL for Conda Forge or something. Well, let's see. So this example here says you can just type the name. So that should work. Let's see. Adding Conda Forge to Anaconda Navigator. Yours worked, Richard? Okay, so Lucia, is yours still not allowing you to do that? If you type in conda-forge and then enter?
No, but let me try it again.
Okay. So yeah, if not, we can go to the command line and basically run this command that's shown here. Except for, yeah, you get rid of the package. Oh, right, this isn't it, never mind. You want to add Anaconda. Let's see.
Wait, it worked. I
Okay,
think I
great.
just misspelled something wrong.
Okay. So yeah, for everybody else that now hopefully has a Jupyter Lab thing open, just another thumbs up check. Who's at this point?
I'm still installing the packages.
Okay, yeah, it'll take a while, no worries. But yeah, so then once you're here, the main thing that we're going to be working on is this thing called a notebook, which is basically just an interactive way to run Python code. So to check certain things, for instance, we can import pandas as PD. This is just the standard way that it's done. And then to run a cell, you can either click this run, or you can, within the cell, click shift and enter, and that'll run it. And assuming that everything's installed, we won't get any errors. Let's try importing something nonsense like that. Whoops. Import some random thing, and it should give an error. Yeah, so if the package didn't install correctly or your environment wasn't activated correctly, you'll get some error like this saying that you don't have that module. But yeah, let's go back to pandas as PD. And then, so let's just show a real quick example of the power of pandas. So I'm going to, let's see, let me open up my file browser here. And I'm just going to drag and drop one of the integration summary standards in here, the CSV file, if my computer doesn't freeze while I'm trying to run everything at the same time. So just drag and drop that in there. Now you can view this as is just within Jupyter here, and you can see that it's just that table that we had from Excel, but we want to read this into pandas. And so pandas has a nice built-in function for this. So I'm going to make a new thing called a data frame. So I'm just going to call this data. This is a variable. I'm going to do panda PD because we imported pandas as PD.read CSV. And then I want to tell it where that file is. And since we're in the same directory, I'll open up a quotes here. / is the shortcut for look in the same directory. And then I might be able to tab complete. Yeah. So just start typing it like that. So this is telling pandas, go find this CSV file. It's called this, and it's in the directory that we're in right now. And I'm going to shift run that, and hopefully it'll find it. It's really slow. Okay, so no problems. And now if we want to look at that, we can just type data like this. And the nice thing about Jupyter, it'll just output all the stuff from that table. So now we have this stuff loaded in Python, and we can start to do all that math that we've been doing in Excel with these columns, or we can split things up and all kinds of junk. So I'm not going to go into that in detail today, but this is where we're going to be going on Wednesday. Okay, so another check. Who was able to get Jupyter Lab or a Jupyter Notebook running within Anaconda? And then maybe at least get to this point where you can import some modules. So are we still on the installing packages thing, or is anybody stuck on making an environment still?
So to open Jupyter Lab, do you just press the play button?
No, so you'll go to the home tab once you've got all those things installed, and it should pop up here. If it doesn't, then you can click this refresh button at the top right. Okay, so yeah, so this is kind of where we want to get to today. And then actually would like to have you guys download the code that I've been working on so that you have something to look at. I'll be updating this. So the version we download now isn't necessarily going to be complete, but I want to make sure that we can get this running as well. So let me grab the URL and I'll throw that in the chat. So if you're at the point already where you've got a Jupyter notebook running and you've made a folder for Chem153, then you can go to this URL. And then let me make sure I can still see chat and participants. So this is a, well, okay, thumbs up real quick. Who knows what GitHub is, or at least has heard of it? I'm not expecting many of you to have. A couple people. So GitHub is basically a website that allows you to upload code and share it with other people and work on it together. We're not going to be doing most of the features that GitHub has that make it so useful, but I am going to be using it to give you guys like some pre-built Jupyter notebooks and some data files and code and stuff like that. So that repository that I just linked to, if you go there, you should be able to download the code by clicking on the green code download button, and then I would recommend just downloading the zip file. And then once you do that, you can move it into your repository or your folder that you just made, and then we can extract it there. All right, so is anybody still installing packages or creating the environment?
I'm still installing packages.
Okay, no
I'm
worries.
still downloading.
Still downloading the installer?
Yes.
Okay, yeah. Sorry about your Wi-Fi. But yeah, so anybody able to download that zip file already from GitHub?
Yeah.
Cool. So once you extract that, why don't I also download it? Download zip. Show it in the folder, and why don't I just drag and drop? So can we extract it from here? I'm not actually sure if there's a built-in thing for open it. Yeah, so that doesn't work. So you might have to go into your Windows Explorer and navigate to wherever you have this folder. So where is that? Is that on here? Documents. I always forget where all of my things actually end up living. Nope, I might need to go to C code. There it is. Nope, C users. Here we go. Code. There it is. So yeah, once you navigate here in your file explorer, then you should be able to extract it. I'm going to use 7-zip because that's my preferred program. And that should reload in here once you go back into it. And so within here, in this notebooks folder, there should be this standards processing IPython notebook. And opening this should hopefully work. There might be some extra little packages and things that I've installed to make this repository that you might run into issues with. So for instance, this IPython core thing might not work if we run this. Nope, it read it, so that's fine. Oh, I have chat hidden, 1 second. Okay. So, okay, I guess we're losing people here, but that's fine. everybody, well, everybody except for Lily, have their environment made and Jupyter Lab open? Or is anybody not at that stage yet?
I'm just like having a hard time opening the notebook. It keeps giving me like error messages.
So from this home tab, you're either clicking this launch or this launch.
Yeah.
And what are the error messages saying?
Like when I click on the Anaconda, when I click on the notebook itself, well, like because I opened Jupyter Lab as opposed to the Jupyter Lab notebook one.
Okay.
Is that like wrong or?
No, it should be fine. So if you launch Jupyter Lab, it should automatically open a new browser window.
Mm-hmm.
And then it should basically just be in like wherever your user directory is. So I've got a bunch of crap in mine. You probably have not as much stuff. But do you see like this kind of window minus all this stuff, something like this?
Yeah.
Okay. And does it have just a notebook open that says like Untitled at the top?
Yeah.
All right, you can close that. And then make yourself a folder where your code and stuff is going to live. We're going to be saving files and stuff in there. So you can make it wherever you want. You can put it in your documents, like where your stuff is, wherever you want. It's just, this is just your file directory that's on your computer already. So I happen to just put mine in code and then Chem153. So then have you downloaded the zip file?
Yeah.
Data equals PD. Okay. So once you've extracted that, like I said, you'll have to probably go into Windows Explorer and then navigate to wherever you made this thing and put the zip file to extract it. But then we want to run into this notebook GCMS standards processing, and it looks like Richard encountered a problem with something. So we'll see what happens. I haven't run this in this environment yet, so I might run into the same issues. And most of this stuff is just, this is called Markdown. So like if you double click on these cells, you can basically include styles and writing within Jupyter notebooks, which makes it easy to explain things. So that's what I did here, which has like a lot of this text and whatnot. But the actual code files are these things. So Richard, did you go through and run the cells in order? So that's one of the downsides of Jupyter notebooks is like you can get your what's called your state kind of messed up if you run things out of order. But if you go through and run each thing in order, make sure that they're imported correctly, then yeah, so that works for me once I run there. But you need to make sure that you run all of the code cells in the order that they're in the notebook. So thumbs up from people who have opened this IPython notebook and have been able to run at least this first cell. Okay, well, I know Richard has, but nobody else is quite there yet. Are we stuck on getting the zip file extracted in this same directory?
No, I'm about to open Jupyter.
Okay.
So I'm barely gonna get to that point.
Okay, no worries. And yeah, so as I mentioned on last Wednesday, our discussion on this Wednesday is not going to go into a lot of detail about Python as a language itself. I would really recommend doing some work on your own. Like I said, those free resources to kind of get a little bit familiar with like the formatting and the syntax of Python. So like defining what a function is and what imports do and things like that. If you have questions about this stuff on Wednesday, I'm happy to go over some of that stuff. But if I spend a lot of time going over the basics of Python, then we won't get to the actual data analysis part. And if it turns out that we need to spend some time doing the basics, then we can schedule an additional time to meet again optionally to go over some of these basic things. But yeah, the gist of this notebook is it goes through essentially what we already did, including the step of making the summary report, which was already done for you guys. But I go through and show you how to do it in pandas instead of having to go through manually in Excel and like copy the values and pivot them and stuff like that. So you're able to do that really quickly in just a couple lines of code in Python. So I'm not going to go through all this right now. We'll go through this on Wednesday. But we can get to this point, and I just want to make sure that everybody has a notebook that is able to run these things. So Richard, were you able to get the pandas import to read as long as you ran these cells in order? Okay, so is it this cell? It's sorry, cell 5 that's not working. And actually, out of curiosity, are you on Windows or Mac? The thing that's on the GitHub, it includes instructions for how to like install this whole thing from scratch. But as long as you extract it within the environment that we just made, it should work as is. The code that I have on the main README tells you how to like install it into a brand new environment, which you can do if you want, but this should be fine. Okay, so another thumbs up. Who has been able to open this notebook file and run at least this first cell? Great, we've got a couple people. So those of you who have not been able to get here yet, are you still just installing packages and waiting for Jupyter to open up? Or Lily, did you finish your install of the installer yet, or your download of the installer? Still installing. A couple people still installing. Okay. Well,
yeah, I was able to download it, but now it doesn't want to open. I'm having trouble opening the Anaconda.
Okay. So you're on Windows 7, right?
Yeah.
You might need to do the 32-bit installer, which I maybe should have made that explicit before you downloaded it. But let me think here. There might be a way to get this to work entirely online for you. I'll look into that a little bit. So if you're not able to get Anaconda working by Wednesday, try to let me know, like kind of in the afternoon, and I'll look into figuring out a way to fix that for you.
Okay, thank you.
Yep. But so for everybody else, I hope we've all at least gotten to this point. I don't want to belabor the point too much or spend a lot of time here because we're going to go over it again on Wednesday, plus some extra stuff we'll code together. But yeah, so does anybody have any questions or problems that they're into or anything like that before we kind of wrap up for the day? Okay, so like I said, I'm going to do a little bit more work on this GitHub project before Wednesday's class. So you'll have to, before we do the actual lecture, you'll probably have to re-download the zip file and extract it again. Or if you want some bonus points, you can look into how to use Git yourself, and then you can basically download the repository using Git and then check out the branch that I'm working on. And that way you can just download the changes that I make without re-downloading the entire folder by itself. But I won't make you guys do that. It's easier just to download the zip file and extract it again. Okay, let me go back to the PowerPoint real quick and just make sure that there is nothing else to talk about. So yeah, I'll upload the recording from this as soon as it finishes rendering after I stop recording. And I'll upload this as well, which has at least some of the the instructions for how to do what we just did, including the packages, I think, although I didn't include Jupyter Lab here. This just says Jupyter, install Jupyter Lab instead, but I think we're all at least at that point. So, okay, I'm ready to wrap up unless you guys have any lingering questions or anything like that. Okay. Yeah, if you run into any problems or need extra help, ping me on Slack. I'm happy to help. And if not, I will see you guys Wednesday evening and we'll do some Python stuff.
Thank you, Ben. Have a good day.
Thanks, Ben.
Thank
Yes,
you,
too.
Ben.
Bye, everyone.